Thank you, Roman. And I'll follow his excellent presentation with potentially mine. Good afternoon, everyone. I'm Riccardo Verzeni, Director of Software Engineering at LINX. And basically, Roman introduced, different use cases for Containerlab, and I'll provide a real use case that the software engineering team at LINX had with Containerlab. So this presentation will cover general overview of LINX network automation, the corresponding UAT environment, the actual setup for LINX UAT and dev LANs that was created with Containerlab by our engineers, and pros and cons that we found, and future developments. So this is a general representation of the three main automation platform we have. NCA stands for Network Configuration Automation. I did a presentation in the past about it. And fundamentally, it's the first automation platform that was ever built at LINX. It's a supervised synchronous multipurpose switch config management tool. And it revolves around effectively a job scheduler, Jenkins, that runs some Ansible playbooks that ingest the state of the network from our technical service inventory, expands it via some templates into syntactically correct vendor-specific configuration, and then pushes them into LINX IXPs via a set of APIs, which is called Napalm. You probably might be familiar with that. And all of this is basically great. The only problem is that it wasn't really very scalable, very reliable, but not very scalable. So we built a newer version, which was basically unsupervised, asynchronous, and member-facing switch config management that relies on messaging queue and some consumers. Each message contains basically a specific action that you want to perform on a switch. And that information gets complemented with some extra information coming from the APIs. And then, again, using the APIs in Napalm, we push those changes into the network. So the main difference is that NCA kind of replaced the entire configuration for the switch, and NCA 2.0, it just merges a very specific member-facing change. And if you saw Mike's presentation when he was talking about OMS, or the management system, the provisioning part of the OMS is powered by NCA 2.0. Then we also have the root server automation, which is using pretty much the same components of the NCA 2.0, but the consumers, instead of creating some small snippets of configuration that get pushed into the switches, they instead create an entire full configuration for a root server, and then twice a day they push this configuration across all the root servers in all LANs. This is a more general schematic of the different layers. So you have the data layer, which represent the admin state of the network devices. So you have the technical service inventory data, which is where we basically keep the majority of our data, and is used by the tree platform. And then the user order, which is specifically for the NCA 2.0, as I mentioned, for instance, when a person orders something by a portal. And then for the root server, you also have external data sources, source of authority like Routinator or other third-party DBs. And these are the automation layers, so the three different platforms. As you can see, the major difference between these two is this one is kind of has like one template per vendor OS, and then creates fundamentally full configuration out of this, while this one has multiple small templates for creating multiple snippets of configuration depending on the action that we're doing, like, for instance, provisioning a port or a PV LAN and so on. And this, of course, is the root server automation. So this represents the full configuration of the root server. And as you can see, basically, these are the different kind of vendors per color. And the yellow and the red one represent an hypothetical new vendor. OS gets introduced in the platform. And the network layer is just the different LANs. So here an example is London 1 with a mix of Juniper and Nokia devices, London 2 with EdgeCore, and hypothetical new LAN with new type of new vendor switches and root server. And so all of this, obviously, in order to not break, needs to be thoroughly tested. And so we have a UAT environment, so user acceptance testing environment, which consists of a mirror-like replica of each production component. And fundamentally, you can test it manually, meaning that you access the UAT version of the application and you perform the same operation you would do on production, but in a safe environment. Or you basically had automated testing being triggered when every single time that there is a change in the code repository of any of the component that creates basically this automation platform. And yeah, so in order to have end-to-end testing and integration testing, you need to eventually interact with the devices. Obviously, you cannot interact with live devices, so we need some form of replicas of our LANs in where we can safely do that. In the past, it was just a very small amount of physical devices dedicated to it, plus some vendor-specific virtualization. But now we use Containerlabs for that, and that allows us a much more higher flexibility, as you can see here. So in the past, we just have very small, as I mentioned, labs. We can perform those tests. Now we have this, basically the UAT and dev LANs that are being created by LINX engineers. So we have 3 dev LANs and 3 UAT LANs. All of this is done by Containerlabs and with the different vendors. The main difference is that on the UAT ones, we are running the automated testing. And on the dev one, as you can see, I have also links between the different switches, so it can be used to pass traffic through them and perform other kind of testing. The pros and cons of this, of course, as you probably got from what I've been saying so far, is that we went from a very limited amount of switches to a quite complete kind of testing lab. So Containerlabs provides fast and low-cost switches fabric setup for LINX network automation supported vendors. Allows software engineers not to compete with network engineers on who actually gets the lab for performing their tests, and potentially break like CI/CD pipelines for software in case that we cannot use the lab for testing the latest update on the automation. And well, for the first time, software engineers can also make modification on the setup of the lab, the one which is they are allowed to, because well, we just have to change a config file. It's not very difficult. We just need to be understand enough of the configuration to know basically what we're going to change there, and especially if we need to create links between the switches, that's very easy with this. Basically. And the cons is that sometimes switch metrics, like light levels, in and out interface errors are not simulated correctly. So when that happens, we have to fall back to the physical devices again, but this is a corner case compared to the overall majority of the testing use cases. And future developments, we're interested in, as you saw basically in the UAT LAN, to actually start testing a little bit more complex test scenarios, so generating traffic between the switches and being able to test automated processes like quarantine testing that we already automated as part of the self-service for Portal. And in the future, we think that this Containerlabs would be definitely great for powering kind of testing of new, more complex tools, or automation scenarios, for instance, network self-healing. Thank you very much.